Here we have a standard scientific notation problem. We have this quantity, 4 times 10 to the 4th, times this quantity, 5 times 10 to the 6th. That's all over 1 times 10 squared. What these quantities really are, they're all really just factors that you can just group them like this. So this is the same thing as this, really. And then after you do that, you regroup the like factors, and it looks like this. You have the 4 times 5, and you have the 10 to the 4th times 10 to the 6th. That's still all over 1 times 10 squared. Once you have that all done, you have the 4 times 5, which equals 20, and then the 10 to the 4th times 10 to the 6th. You can keep the 10 here because they are like bases, and all you have to do is add the 4 and the 6. And that's still over 1 times 10 squared. And then once you have all that, once that's all done, the 20 stays the same, but then you have to add the 4 plus 6 equaling 10. So it will be 20 times 10 to the 10th over 1 times 10 squared. After that, since in scientific notation the first factor has to be greater than 1 but less than 9. Since it's 20, it becomes a 2, and since 20 is really 2 times 10, it would be times 10 to the 10th. And that's still over 1 times 10 squared. So you keep it like that. And then the 2 becomes a 2.0 times 10 to the 11th because you have to add the 1 and the 10. And that's, again, still over 1 times 10 squared. So you have this. And then in scientific notation, you have to divide the first factors, and then you divide the like bases. You keep the like base the same, but then you subtract the 2 exponents. So then it becomes 2.0 times 10 to the power of 11 minus 2. So your final answer would be 2.0 times 10 to the 9th.